At Rolls-Royce, we believe in the positive, transforming potential of technology. Throughout our rich heritage, we've pursued more competitive power, developing ever cleaner, safer, groundbreaking technologies that shape the world we live in. We've created the world's most efficient large aero engine, powered nuclear submarines, and enabled land speed records. We've developed game-changing engineering solutions for supersonic jets, and even supported NASA missions on the edge of space. We disrupt, we challenge convention, we champion new solutions. We pioneer the power that matters. We're always looking forward, creating an environment where our people can be at their best, shape the future, and work on incredible projects that matter. We give them the freedom to grow, challenge, and be brilliant. We collaborate, innovate, and embrace different ways of thinking. We're pioneers. Together, we'll advance beyond tomorrow.
Hi, I'm Nicola Swanee, Education Outreach Manager at Rolls-Royce, and Rolls-Royce is proud to support the Big Bang Fair, and we have done ever since the very first one way back in 2009. So welcome to our Rolls-Royce session. You'll hear about the ACCEL programme, which stands for Accelerating the Electrification of Flight. You'll meet Phil, the pilot, who's going to be flying the Spirit of Innovation to beat the world speed record, and from Laura, one of our engineers who's been working on the ACCEL all-electric aircraft programme.
Hello, my name's Laura Wood and I'm an electrical engineer at Rolls-Royce working on the ACCEL project, where we're developing groundbreaking technology.
And I'm Phil O'Dell, I'm a test pilot with Rolls-Royce.
And we want to welcome you to this hangar here in Gloucestershire Airport to give you an overview of the pioneering project, where we are championing electrification in aerospace and also working towards more sustainable flight.
But it's not just about records and record-breaking aeroplanes. It's about technology like this. This is the Airbus City Airbus that's flown recently, powered by Rolls-Royce technology. Incredible project, and we'll talk you through that story as well.
And the City Airbus project is only the start. You can see on screen a futuristic concept of what travel might look like. And that's where it's over to you, what travel could look like in the future. How will we travel? How will it be powered? How can we make it more sustainable? And that's a project within our team and Rolls-Royce that we're very excited to take on towards our path towards net carbon. And we just are going to hear as well from our team and how we're overcoming those challenges.
Aviation is around 2–2.5% of carbon emissions. The pressure to go away from a fossil fuel source to another technology, largely electric, is overwhelming.
The social connections and movement of goods and technology and people that we can do through flying is fantastic, and we have to find a way to decarbonise that but without losing those social goods.
The reason we're championing electrification in aerospace is we see it as part of our overall strategy. Develop the gas turbine, champion electrification, and also sustainable aviation fuels. We're going to need all three to go to zero carbon.
The project that we're undertaking is all about making a plane go very, very fast. And as part of that, we're investing in new technology that we hope is going to enable cleaner, more sustainable aviation. But we also hope is really inspiring. This is about how do we start to champion electrification in aerospace? So how do we show people what is possible?
So you've heard all the really good reasons why we're doing this, the sustainability, the race to zero. Really exciting time around us now, and a really exciting future, and a future for us and a future for you in electric aviation. Let's now talk a little bit about the Nemesis NXT, this aeroplane. Only 10 of them built, designed in America by a chap called John Sharp. There's no manufacturing line, there's no manufacturer. They're built individually by their owners. Why is it such an incredible aeroplane? Well, it was built to go fast. It was built to break records in its original internal combustion version. And it's done that. It holds records in its class already. We stripped all of that out and put all this brand new technology in. And Laura's now going to take you through that technology.
So we're going to start at the battery, and the battery is the energy for the full system. And it's built up of 6,000 of these VT6 cells that you can see in my hand. And as you can imagine, 6,000 of these cells generates a lot of heat, which is a significant challenge for our engineers to overcome. And that battery is controlled by power electronics, which you can see stacked on the side here, battery. And that's going to be controlled by Phil using the throttle in the cockpit. And that's what's going to be driving the 3 motors, which you can see in the power stack at the front of the aircraft here. And those are going to be running at over 500 horsepower, which will spin the propeller at up to 2,400 RPM, which is going to be driving the aircraft to beat 300 miles per hour plus world speed record.
Wow. Thanks, Laura. So I get to do the easy bit, which is to come along at the end of all this incredible technology, sit in the cockpit and fly the aeroplane. I am acutely aware of all the work that's gone in from Laura and from lots of others here at Electriflight with Yasser Motors and with Rolls-Royce. It's remarkable what's gone into this project to date, with more to come.
So you've heard a little bit about our Accel programme, accelerating the electrification of flight, and we need fantastic electrical engineers to join our business to help us in our drive to reach net zero. So you'll hear from Laura about her career as an electrical engineer with us, and also from some others of our graduate trainees at Rolls-Royce.
I'm a graduate engineer, where prior to joining Rolls-Royce, I studied electrical and electronic engineering. And that's given me the opportunity to join the Accel programme. And within the Accel programme, I've had lots of different opportunities and tasks that I've been involved with. One of them being the design of the cockpit, and how that's a serious challenge in that it's a completely new space and what's it look like for an electric aircraft. I've also been involved in many different testing elements, so such as our battery testing, our landing gear, and also involved with the Iron Bird rig testing, which you can see to the side of me here. And this is a testing rig which has got the full system, so you'll probably recognise a lot of the hardware that you've seen on the screen previously, such as the motors, inverters, propeller as well, where we've actually taken this rig up to full speed. And that's just a bit of a flavour of some of the tasks that I've been involved with and the opportunities that an engineering degree has given me to truly be at the forefront of the electrification of aerospace. And I now want to pass over to some of the other young engineers and some of the opportunities and challenges that they've faced in their career.
So we're at the start of a journey to what we call the third age of aviation. So the first age being propeller, the second age being jet, then into electric aviation. Rolls-Royce have been pioneers through all of that period. As we look forwards, we want to be inspiring because we want to attract the next engineers, the next scientists in to push us forwards.
I'm Bethany Hall. I'm an electrical engineer at Rolls-Royce. My school took me to an IET lecture about the Bloodhound supersonic car, and I sat there and thought, this is so cool. I really want to be an engineer. And now it's 10 years later, I'm a qualified electrical engineer and I'm part of Team Accel, building the world's fastest all-electric aircraft.
I'm Matthew Morris. I've always been interested in electrical engineering, and now I'm at the forefront of what electrical engineering is, especially within aerospace.
It'll be great to inspire the next generation of engineers and pilots into this new technology.
Our aircraft, the Accel aircraft, is really the first step into how to enable electrification in aerospace.
So you've just heard about our graduate opportunities. Now you're going to hear from Phil, our pilot for the Spirit of Innovation aircraft, and hear about his amazing career so far.
So my job title here at Rolls-Royce is the Director of Flight Operations. So I'm accountable for operating our aeroplanes that we use within Rolls-Royce. So that's a 747 flying test bed, it's a Spitfire, it's a number of other aeroplanes that we use, and I have to keep them safe in operation, and I have to keep the people that fly on those safe as well. My last job before joining Rolls-Royce 19 years ago was as a pilot initially for the Royal Air Force, flying a lot of fast jet aircraft, and then finishing up as a test pilot. And it's that allowed me to bridge into this role initially as the chief test pilot for Rolls-Royce, where I looked after our flight test and took our products into aeroplanes and ensured that they were fit for purpose. For my 18 years in the Air Force, and getting a career generally in aviation, there's lots of routes. I started by flying light civilian aeroplanes and worked my way up from running the reception desk at a flying club into learning to fly, into adding various ratings and getting myself in a position where at the time I could join the Air Force because that's what I wanted to do. There's lots of other ways. The Navy employs pilots, the Army, through the Army Air Corps, employs a lot of pilots. So a number of opportunities. Civil aerospace is taking a little bit of a hammering at the moment, as we've seen, but it will improve, and a little bit more of that later as we sum up at the end. But the biggest bit of advice is to do your research. Lots of articles, lots of help, lots of people in aviation that will help other people outside of aviation. It's a very family thing. But also never to give up, just to keep going, always. When you get knocked back, you get up and you go again.
Great advice there from Phil. Now you're going to hear about some of our other graduate opportunities in Rolls-Royce.
I always thought I would follow an academic path, but once I started talking to Rolls-Royce at a career fair, it all sounded like the perfect fit. A chance to create as well as to think.
The graduate program isn't about just sitting behind a desk. It's very hands-on.
In my 3 years here, I've had the opportunity to work across functions, sectors, and countries. And I've recently moved into my first management role, Sales Director for Civil Aerospace.
It's amazing that as a graduate, I get to see how Rolls-Royce operates on a global scale.
Good communication and leadership skills can be just as useful as a technical background.
I started programming when I was doing my degree. I was quite happy to see that my first role involved coding and scripting. This was a proper job right from the start.
My background is in pure and applied mathematics. I like to turn a concept into something real, something I can see.
My proudest moment was developing a new customer strategy mapping system. It was so successful that it's now the standard process across a number of our defence accounts.
I felt excited that even as a graduate, you would be part of a team capable of building an engine made of more than 10,000 components.
Even going on short-term attachments, you're constantly learning, being inspired by the people around you.
I'm really proud to be part of Rolls-Royce. People here don't think in a specific way. Everyone brings something different to the table.
So you just heard from some of our graduates. Now you're going to hear from some of our apprentices at Rolls-Royce. So we offer apprenticeships post-GCSE, advanced apprenticeships, and post-A-level degree apprenticeships. During a degree apprenticeship, you can study for a degree and it's all fully paid for by the company. So you're earning while you're learning.
I wanted to see what it was actually like to do a job rather than just learning about doing a job, and I've got that.
The main reason I chose to do an apprenticeship was because of the sponsored university, and I think getting out there into your career as early as possible is the best thing to do.
It's just what suited me best with being a kinesthetic learner. It gave me the practical and theory.
I chose an apprenticeship because it suited my learning style better.
To get real-life working skills.
I wanted to do an apprenticeship because I wanted to do something more hands-on and get a qualification for it.
I did a placement with Rolls-Royce when I was in school, and this inspired me to apply for the apprenticeship. I think they're far better than going to uni. You get the practical side, which you would never get at uni. It would all be theory-based.
Yeah, I'd say, if not better. We actually go to university on block release, so we're there weeks at a time. So people that feel like they'll miss out on university life are it's not something we miss out on at all.
I'm a degree apprentice, so I do two at the same time.
Apprenticeships are better than going to uni because you get a salary in the end.
I'd say it's better because you get the experience and also the degree.
I think an apprenticeship is better because you're getting on-the-job experience as well as the qualification.
I think apprenticeships are better than going to university, particularly because with apprenticeships you can go to uni.
The Spirit of Innovation is an all-electric aircraft designed to go break the world electric speed record.
Awesome is an overused word.
But if you put 550 horsepower in a little airplane like this, it's going to go like the clappers. And it does.
It's an incredible, remarkable aeroplane for many, many reasons. The electric powertrain that's in the aeroplane is utterly cutting edge. It's a great aeroplane to go and break records with, but also to prove the future and the next steps for electric aviation.
It's been a really long road to get to this point. It's been 3 years, it's been countless hours designing, building and testing this fantastic aircraft.
We thought, well, how hard can it be? Well, it turned out it's pretty hard, but we've managed to produce an incredible machine.
I think the key thing about breaking the record is about demonstrating how fast this technology is going, and therefore how soon it's going to be in all our lives. So with our aircraft, the spirit of innovation, we want to go and break airspeed records, and crucially we want to go break the 3-kilometre record, the 15-kilometre record and the time to climb record.
The current record for the 3-kilometre challenge is 213 miles per hour. We're hoping to go considerably faster than that. Over 300 miles per hour would be remarkable.
We want to almost add 50% to the existing record. That's never happened before in the history of aviation record breaking. This is really a tremendous challenge that we're taking on for ourselves. Electric aviation is really disruptive. It requires new technology, it requires new ways of working, it requires a lot of new thinking. How do we design a powertrain that gives us enough power to propel the aircraft so we have more than 500 horsepower on board? How do we design a battery that can hold enough energy? So the energy on board our aircraft when we undertake the record run could power about 250 homes. One of the great things I think we've done in this project is the way we've tackled these challenges. We've brought together really two very different organisations in Rolls-Royce and Electriflight. So Rolls-Royce, a company with a long history in aerospace, some great people, some great technology. In Electriflight, a young startup, but incredibly agile, able to tackle challenges in a different way, able to challenge us in how, as Rolls-Royce and how we approach programs. And really, I think this has been mutually beneficial.
It's been a fantastic opportunity to work with such a traditional large-scale organisation that's got so much sort of legacy in aerospace. That bigger organisational perspective and that drive for safety has been really important, but at the same time Electriflight has brought some fantastic dynamic, fast-paced sort of engineering capability, and that's how we've managed to deliver the aircraft to such a great level in a relatively short amount of time.
We know that it's an unusual airframe. The reason that it's so fast is because it's a slightly awkward thing to fly. It's more like a jet engine to operate because the throttle lever is beautifully smooth, there's no vibration from the aeroplane, so it's a lovely thing to fly, albeit you've got to keep your wits about you. The motors and the propulsion mechanics and the propulsion management systems are fantastic. The motors are virtually silent when you sit in this airplane. I think the future clearly is from electric propulsion. We just need to get the energy storage system slightly more efficient, I think. So batteries at the moment are holding us back, but electric propulsion, definitely the future.
The Schneider Trophy was a race series in the 1920s and 30s where people competed to build the fastest seaplane. And Rolls-Royce was invited to come into this competition and develop an engine. And we did. We developed the Type R engine that ultimately went on to win the Schneider Trophy and secure it for the UK. But it was a really pivotal time for us because it brought together quite a small team of engineers to just focus on the challenge of how you build an engine that can go as fast as possible. And when we think about what we're doing now in the spirit of innovation, where we're trying to build an electric aircraft to go break airspeed records, to really go demonstrate what's possible, we just found so many similarities, not just only in the objectives, but in the way that we've tried to work as well.
Pilot, last person in the airplane, but it's so, and I'll get emotional saying this, so wouldn't get there without the hundreds of people across Rolls-Royce, Electriflight, YASA, the ATI, the government. I've never seen a team come together and achieve what this team has done.
Thanks very much, guys. Thank you.
I don't think I've ever met as many clever people in one room as I've seen over the last few years. You know, we've got some really clever people, and they just seem to have boundless energy. It's been a tough project. It's a roller coaster of a project. You know, we have 10 steps forward and then you get 2 steps back and everybody's a little bit down, but you know, come Monday morning they're all re-enthused and away they go again, and they just keep plugging away. What we see behind us is a testament to the tenacity that they have to keep going, and it really is an amazing thing, and we're very grateful to them, and fingers crossed we can set some good records.
It's just after 7:30 in the morning. We're going to go for the 3-kilometre record today, that's for sure. The weather outside is beautiful, it's a perfect day. Got my paperwork, I've been running through the sortie, running through my checks, making sure I'm ready to go, and I'm excited.
Morning guys, everyone ready? Eyes in, flight brief, flight 20, 3-kilometre world record attempt. So standard operation, we've done this before, it's just a repeat, but this time it's a score. It'll be fill flying, 75% takeoff, 75% in the turns, full power in the runs. Main priority, safety. Just do our normal jobs, keep it safe. Any problems, we'll knock it off and have another go. All right, good luck, let's go for it.
So on the day, my main responsibility is to fly the aeroplane, but there's preparation around that. I need to have learnt the route, the track, how we're going to turn off that track, how we're going to turn back into that track, what heights I'm going to be at, all the contingent factors in assessing that. One of the last things before I take off on the record run is a mental rehearsal where I run through every step, and I run through those steps physically as well. So I'll be at the end of the runway stood next to the aeroplane, and I physically walk through the route, and I physically walk through what my hands are doing. You'll see me move my hands around, you'll see me move the throttle, and you'll see me move the flap, move the gear, pull the stick back, turn. Yeah. As we get to those last moments before I get airborne, I've run through all of my checks, so it's very procedural, because in this dynamic environment, I think that's vital. And it slows me down a little bit as well, and calms me down a little bit.
14.1, 97, 96, 97. No reds, no ambers, no attention getters.
It's easy to get taken away with the journey, the briefing for the record run. You can see the excitement, I can feel the excitement. So I'm slowing that down. That mental rehearsal where I walk through tries to slow me down. And I just try and quieten myself a little bit and breathe.
And confirm the prop clear. Prop is clear. Ready run. Ready run. TM Merlin's ready. TM ready. Merlin ready departure. Merlin cleared for takeoff. Start. Stop one. run to.
We've broken a record that already existed, but crucially, we've broken it by a phenomenal amount. I can't think of a better way of demonstrating just how fast this technology is moving and how soon this is going to be in everybody's lives than the way that we travel. I think it's clearly demonstrating that we're getting into the third age of aviation.
These records prove electric aviation is absolutely and utterly here to stay in many forms. There's more to sustainability than just electric aviation. We're entirely engaged in that as well. But from this project, electric aviation absolutely works.
Look what you can do with electric propulsion. You can create this amazing machine, and anybody, certainly in light aviation, will look at this and think, holy moly, that is an incredibly impressive machine, and we and Rolls have done it.
People often ask how I'll look back on this in 20 years. I don't entirely know. It depends what the effect of this is, but I think it's going to be huge. So I'll be proud of my contribution, proud of the team as well, and proud of what we've achieved to have actually done something. My kids have asked me what I do for sustainability because it's their world, and I've genuinely wanted to do something and be part of a company and a group that combine to do something about it, and passionately feel we have.
Throughout this project, we wanted to inspire you, the next generation of scientists and engineers into aerospace, and really show what a fantastic opportunity it is. And if you're interested in finding out more or looking for some learning materials, please refer to our website, rolls-royce.com/STEM.
So thank you for spending your time today and coming on this journey, and for the opportunity for Laura and I to talk about our careers and how we've got into aviation and how much we've got out of it. It's been a great privilege and enjoyment for us, and also for the opportunity to tell you about Project Axel and that really exciting future for all of us in aviation. Thank you for your time, and I hope to see you again soon. Bye-bye.
Bye.
Thank you for listening. We really hope that this session has inspired you as you've heard about the fantastic potential that the STEM subjects offer for future careers, particularly in the drive for more sustainable power solutions and in the drive to reach net zero. So best of luck in your future careers, and keep doing STEM, and thanks for listening. Goodbye.